Activity 3.7, broken yardstick. Jason and Liliana need to measure some pictures so they can buy picture frames. They looked for something to use to measure the pictures, but could only find a broken yardstick. The yardstick was missing the first 2.5 inches. They both thought about how to use this yardstick. Liliana said that all they had to do was measure the pictures and then subtract 2.5 inches from each measurement. Is Liliana correct? Explain your reasoning. Well, let's see here. If I measure something and it is 2 inches, right? I'm sorry, and it's, I don't know, 4.5 inches, right? It would normally say 4.5, but if I started at 2.5, it would be, it would measure, let's see here, 4.5, 6, it would measure 7 inches. And so I would take away 2.5, and that would leave me with 4.5. So yes, Liliana is correct. Okay, because the yardstick starts at 2.5 inches. Okay, so they measured the first picture's length and width to be 11 inches and 9.5 inches. Okay, and so what are the actual length and width? So if I take 11 inches, I subtract 2.5 inches. That's going to be 8.5 inches. If I take 9.5 inches, I subtract 2.5 inches. That's going to be 7 inches. So the actual measurement is always 2.5 inches less than what they measured with their broken ruler yardstick. Okay. Number 3, define the variables for a measurement with the broken yardstick and the actual measurement. Okay. So define variables. Let B be the measurement with the broken yardstick. And then let A be the actual measurement. Four, write an equation that models the relationship between the variables. All right. So the actual measurement will be the broken measurement minus 2.5. Okay. Or I could think about it like this. The broken measurement is going to be the actual measurement plus 2.5. Okay. So I'm coming up with a situation. I'm trying to understand the situation by doing a basic problem. I'm trying to define variables, and then I'm trying to write an equation for that problem. Okay, equation has an equal sign, and so that's kind of what I did right there. Number 5, complete the table of values for the measurement on the yardstick and the actual measurement. Okay, so if I think about this, if it's this, I have to subtract 2.5, so this would be 8.5. If it's this, I have to subtract 2.5, so it'd be 7. If it's this, I'd have to subtract 2.5, so it'd be 23 1/4. If it's this, I have to subtract 2.5, which would be 18 1/2. If it's this, I have to subtract 2.5, so it'd be 16 1/8. For this one, I have to add 2.5, so it'd be 14.5 on the broken yardstick. To add 2.5, so it'd be 31 5/8 on the broken yardstick. To add 2.5, so it'd be 9 3/8 on the broken yardstick. Okay. Use the table to complete the graph of the actual measurements versus the measurement taken on the broken yardstick. Okay. So if I go through here, we had broken yardstick was 11, actual was 8. So here's 6, 7, 8.5. Oofta. So right around there. Broken was 9.5. And then it was 7. This should be up. The first one should be up there. 9.5. Then it should be 7. Okay. Then the broken was 25.75. I'm just going through the table of values and I'm trying to put them on the graph here. 25.75 and then 23, 1, 2, 3 and a quarter. Right there. 21 and 18. Right about there. 18 and 5/8, right about there. And 16 and an eighth. So about there. And then 14.5 and 12. $31 and 5/8, 29, $9.75, or 9 3/8, 6, 6. Okay. What I'm noticing is they all line up there. Would it make sense to connect the points in the graph? Yes. You can have parts of an inch. So there's parts of an inch here on the X, there's parts of an inch here on the Y, and so since you said yes to both, you can have fractional parts of both. You can connect the points, and they form a nice line there too. All right, so trying to graph those values, which is tricky to do. Then number 8, suppose the yardstick was broken at 5 inches instead of 2.5 inches. Write the new equation for the relationship between the actual measurement and the measurement from the broken yardstick. Okay, the actual measurement is going to be the broken one minus 5 inches, or you take the broken one and it's going to be the actual measurement plus 5 inches. Okay, sketch a graph of the actual measurements versus the measurements taken with the new broken yardstick on the graph with the original yardstick. Okay, so if I go back to the previous page, on the broken yardstick, if it measured 5, it would be the same as 0. On the broken measurement, if it measured 10, it would be the same as 5. If it measured 15, it would for real be 10. 20 would be 15. 25 would be 20. 30 would be 25. And so my line would be below the other one if there was a difference there. Okay. What do you notice about the two graphs? Well, the lines are parallel to each other. What is the meaning of the x-intercept? The point with a y-coordinate of 0 on each graph. So 2.5, 0, and 5, 0 tells us how many inches the broken are broken off of the yardstick. Okay. So once again, with this one, they gave us a problem situation. We tried to work on getting an equation to go with it. Then we made a table of values. Then we graphed that table of values. Then we kind of looked at a slightly different situation and tried to compare the two graphs. Okay. Once again, we're taking graphs and we're evaluating them. We're trying to understand them a little bit. And then from there, we are trying to answer some questions, including trying to come up with an equation that goes with them.